This is the question we want to have a look at on chemistry, and that is about finding percentage, purity and impurity. Now, how do we go about this? Let's begin together. This is the equation of the reaction. Mole, the number of mole in the reaction for the base sodium hydroxide is 2, and that of the acid is 1, because when you see an invisible number here, it means 1. Now, these are the information given in the question. The mass of impure sodium hydroxide is 3 grams in 250 cm3. While Cb is the molar concentration that is mole per dm³ of the base we are looking for in Roman figure 1. Ca is the molar concentration, which is a mole per dm³ for the acid. Va and Vb are the volumes of acid and base respectively. Now, since we have these 4 information, then we can start by using this to find the concentration of the pure sodium hydroxide. Do not forget, in the note I gave at the beginning of this class, it has been written there that it's only the pure part of the impure given solution that will take part in the reaction. Therefore, I'm going to substitute, and the substitution will go this way. After the substitution, then we'll make Cb the subject. The mole ratio here is from the equation of reaction. 1 mole for the acid, 1 mole for the base. So Cb now will be equals to 2 times 0.1 times 30 divided by 25. Let's see that what the value will be. The molar concentration of the pure base is 0.24. 0.24 mole per dm³. Alright. To answer question 2, we have to find the percentage purity of sodium hydroxide. Don't forget, the formula is mass concentration or concentration of the pure and divided by the concentration of impure. So I'm going to find the mass concentration of pure sodium hydroxide now. How do I find that? This one we are given here, which is 3 grams in 250 cm3, is for the impure. And as a matter of fact, it's not yet in the right frame. How? It has to be gram in 1000 cm3, which is 1 dm³. So, but leaving that one for now, I want to find the percentage purity of sodium hydroxide. I need the mass concentration of that pure sodium hydroxide. How do I get that? Now, mass concentration. Mass concentration is molar concentration times molar mass. That means I have known the molar concentration of the base, which is this, of the pure base rather, which is this. So I need to find the molar mass of the pure base. And molar mass of the pure base is molar mass of sodium hydroxide. So molar mass of sodium hydroxide will be calculated by adding all the masses of the elements together. That will be 23 plus 16 plus 1. That will give us 40 grams per mole. Okay, having done that, I can go ahead and find the mass concentration of base, or pure base. Mass concentration of pure base will now be equals to molar concentration of pure base, which is 0.24, multiplied by molar mass, which is what? 40. What does that give us? Now, the mass concentration of pure base, that is sodium hydroxide, has been calculated using this formula to get this. Now, we want to find the percentage purity of sodium hydroxide using this formula, which has already been displayed at the beginning of this class. So, mass concentration of pure sodium hydroxide is 9.6 divided by mass concentration of impure sodium hydroxide now will not be 3 grams. So that means I need to put a question mark here for now, times 100 over 1. I need to find the mass concentration of impure sodium hydroxide. That is the first thing I'm going to do before I come back to this now. The mass concentration of impure sodium hydroxide is calculated by 3 over 250 times 1000 over 1. Why? Anything mass concentration must be in 1000 cm cube, which is the same thing as 1 dm cube. So since 3 grams is in 250, we need to find how many grams will be in 1000, and that is why I did this. Supposing this one is already 3 grams in 1 dm cube, assuming, then that 3 grams, that could have been our what? Mass concentration, 3 grams per dm cube. But since it is in 250, we need to find the amount in grams in 1000 cm cube, which is this calculation. Alright, having done this, which is 12, it is this 12 now that will be used here. Therefore, percentage purity. So the percentage purity of sodium hydroxide is now 9.6, which is the mass concentration of the pure sodium hydroxide, divided by mass concentration of impure sodium hydroxide multiplied by 100. The formula is displayed at the beginning of this class. We got 80%. So if the percentage purity is 80%, definitely percentage impurity will be 20, because when you take 80% out of 100%, whatever is left is for the impurity. But let's do the calculation and confirm that. To find percentage impurity, the formula is mass concentration of impurity divided by mass concentration of impure multiplied by 100. How do we know the mass concentration of impurity? We know that by subtracting the mass concentration of pure sodium hydroxide from the mass concentration of impure sodium hydroxide. And don't forget, mass concentration of impure sodium hydroxide is 12 minus 9.6. And what will that give us? We get 2.4 grams per dm cube. So 2.4 grams per dm cube is the mass concentration rather of the what? Of the impurity. So going back to this formula, percentage impurity will now be this 2.4 divided by 12 multiplied by 100 over 1. That will give us 20%. As you can see, if you subtract 80% from 100%, you get this 20%. That means you could have you can still do it directly by doing 100% minus what? 80% without going through this calculation. Take note of that. It is allowed in any exams. Now, to find the number of moles of hydroxyl ion in pure sodium hydroxide, we use the formula that says number of mole equals to molar concentration multiplied by volume in cm cube divided by 1000. So let us substitute. What is the molar concentration of the pure base? That is 0.24. Multiplied by volume of base given is what? 25 divided by 1000. What does that give us? Now, having gotten the number of mole, which is 0.006 of sodium hydroxide. We will now write sodium hydroxide, we will dissociate it. That means this is called dissociation. We break this down into its ion. And the ions are sodium ion and hydroxyl ion. So 1 mole, there is an invisible one here. 1 mole of sodium hydroxide produces 1 mole of sodium ion and 1 mole of hydroxyl ion. So once 1 mole produces 1 mole of hydroxyl ion, definitely 0.006 mole of sodium hydroxide contains 0.006 mole of hydroxyl ion. Supposing we have, let's assume we have something like 2 here, we multiply this 0.006 by 2 to give us the answer. But since there is nothing like that, so it remains 0.006 mole of hydroxyl ion. So this is the end of this class. See you in my next video. Bye.